Have you ever looked out an airplane window, miles up in the air, and just wondered, how in the world is this thing actually being steered? I mean, there are no roads up here, right? Well, today, that's exactly what we're going to break down. The incredible physics and engineering behind how airplanes are controlled.
But seriously, just think about that for a second. A 70-ton machine moving hundreds of miles an hour with no road to follow and no wheels on the ground. How do you even begin to steer that? It is the fundamental challenge of aviation. And the solution? Well, it's this beautiful symphony of physics and engineering.
The secret to all of it lies in three invisible lines that run right through the plane's center of gravity. First up, you've got pitch. That's just the nose tilting up or down. Then there's roll, which is when the wings bank to the left or right. And finally, yaw, which is the nose swinging from side to side. Every single thing a plane does, every maneuver, is just a combination of these three movements. So to control all of this, the flight controls are kind of split into two teams. You have the primary controls. Those are your ailerons, elevator, and rudder, and they handle the constant moment-to-moment steering. Then you've got the secondary controls, like flaps and spoilers, and their job is to temporarily change the actual shape of the wing for very specific situations. Let's start with those secondary guys and take a look at takeoff.
All right, Section 1, takeoff. To get a massive multi-ton aircraft off the ground from a dead stop, you can't just rely on the basic wing shape. Pilots actually need to bend the air itself, and that's where those secondary controls are absolutely essential.
So here's the core problem, right? Lift is all about speed. But during takeoff, you don't have a lot of speed yet. So how do you generate enough force to lift this huge jet off the ground? Well, you have to cheat a little by changing the wing itself. The solution comes from these things with a super technical name, hypersustentator devices. Yeah, it's a mouthful, I know. But all it really means is there are parts of the wing that can extend and retract on command. Their only job is to change the wing's curvature, making it a lift-generating powerhouse even when it's not moving that fast. You've probably seen these. The most famous of the bunch are the flaps. They're located on the back edge of the wing, the trailing edge. They come in all sorts of forms, from a simple panel to these crazy, complex triple-slotted designs. For takeoff, a pilot will extend them just part of the way, and that gives the wing a massive boost in lifting power.
And working as a team with the flaps, you've got the slats, which are on the front or leading edge of the wing. They slide forward and open up a small gap. This helps the air hug the wing and flow smoothly, which prevents it from losing lift. So together, the slats and flaps let the wing bend the air much more effectively to get that heavy plane airborne.
Okay, so we're airborne, the hard part's over, right? Now it's time for the primary flight controls to take over and do the actual steering.
First up, how do you bank the plane? That is the job of the ailerons. These are small hinged panels way out on the edge of each wing, and they have one really crucial feature. They always work in opposition to each other. When one goes up, the other one goes down.
And the way the pilot controls them is super intuitive. They just turn the control wheel, the yoke, left or right. It looks just like a steering wheel in a car, but instead of turning the vehicle on the ground, it starts a roll in the air. Here's how that works. It's this beautiful, direct mechanical connection. The pilot turns the wheel, a whole system of linkages transfers that motion all the way out to the wings, and boom, the ailerons move up and down. It's simple, and it's incredibly effective.
So, here's the magic. This is the crucial part. The wing where the aileron moves down gets a temporary boost in lift. At the same time, the other wing, where the aileron went up, gets less lift. It's that imbalance, that simple difference in lift between the two wings that causes the whole airplane to roll, or bank, right into a turn.
Okay, so that's rolling. What about pointing the nose up and down? Well, that's pitch control. It's all about adjusting the plane's attitude angle. That's just pilot speak for where the nose is pointing. And the control surface that handles this is the elevator, which is on the horizontal part of the tail. And again, the input could not be more intuitive. To make the nose go up, the pilot just pulls the control column back, towards them. To make the nose go down, they push it forward. Simple as that.
The mechanics are just as direct as before. The pilot moves the column, and a series of linkages transfers that push or pull motion all the way to the elevator on the tail, making it move either up or down. So, when the pilot pulls back, the elevator moves up. This deflects the air, creating a downward force that pushes the tail down. And just like a seesaw, right, with the wings as the pivot, if the tail goes down, the nose has to go up. Pushing forward does the exact opposite.
And that brings us to the final piece of the puzzle, our last primary control, the rudder. Its whole job is to manage yaw. That's the side-to-side motion of the nose. And honestly, it works almost exactly like the rudder on a boat.
The pilot controls this one with their feet. You push the left pedal, the rudder moves left, which pushes the tail to the right, and that makes the nose yaw to the left. This is absolutely critical for making smooth, coordinated turns in the air, and, of course, for steering the plane while it's taxiing on the ground.
All right, we've taken off, and we've steered our way around the sky. Now for what many pilots say is the trickiest part of any flight, getting back on the ground safely. This is all about a controlled return to Earth.
See, landing has its own unique set of challenges. The pilot needs to fly as slowly as they possibly can, which means our old friends, the flaps and slats, are back, but this time they're fully extended. They also need to create a ton of drag to slow down. And most importantly, the second those wheels touch down, they need to kill the wing's lift so the brakes can actually do their job.
And the key tool for that job? Spoilers. These are panels that are built right into the top surface of the wings. During the flight, they're sitting totally flush, hidden away. But for landing, oh, they become absolutely critical. The very moment the wheels touch the runway, bam, these panels pop straight up. This does two incredible things all at once. It creates immense drag, acting like a giant air brake, and it completely spoils the smooth airflow, destroying the wing's lift. This is what plants the plane firmly on the runway and allows the wheel brakes to finally work effectively and stop the massive machine. So from takeoff all the way to touchdown, it's just this incredible dance, isn't it? You have the primary controls doing the moment-to-moment steering, and the secondary controls literally reshaping the wing when it's needed most. All these different surfaces working together in a perfect symphony of physics. It really makes you wonder, what other amazing engineering marvels are hiding right there in plain sight?